Welcome to this ultimate revision explainer. Board exams की tension हो रही है? I completely get it. If you need to compress hours of studying into a highly focused, under 10-minute sprint, well, you're in the exact right place. We're going to completely tear down and rebuild the electric charges and fields chapter. फटाफट high yield concepts और tricky PYQs cover करेंगे. So get ready, because we're moving fast.
Here's our blueprint for today. We'll be conquering 5 domains: charges and Coulomb's law, electric fields and flux, the electric dipole, a rapid important formula recap, and finally, some essential exam tips and PYQs. Let's get into it.
All right, part 1, charges and Coulomb's law. Chalo shuru karte hain with the absolute bedrock of electrostatics.
Okay, so everything starts with Coulomb's law, first published way back in 1785. It describes the force between 2 point charges at rest. Formula bilkul simple hai, right? The electrostatic force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Basically, like charges repel, unlike attract. It's an inverse square law, much like gravity, but vastly, vastly more powerful.
But you might be wondering, why does this even matter? Well, think of Coulomb's law as literally the ultimate atomic superglue. Ye exact force negative electrons को positive nuclei के आसपास orbit coordinate. Furthermore, this exact same electrostatic force binds atoms to form molecules, and ultimately, well, everything we interact with every single day.
Moving on to part 2, electric fields and flux. We've got our foundational force, so now let's shift gears and look at the environment these charges create around themselves.
Listen, exam numericals में सबसे बड़ी गलती होती है mixing up electric potential with electric field strength. Let's just clear this up right now so you don't lose marks. Electric potential is a scalar. It only has magnitude, measured in volts or joules per coulomb. On the other hand, electric field strength, that is a vector. It represents the actual force on a unit positive charge, measured in newtons per coulomb or volts per meter. Direction or magnitude, दोनों ध्यान रखना है यहाँ.
And this brilliantly illustrates how we actually visualize that vector field using Michael Faraday's electric field lines. Notice how they always originate from positive charges and terminate at negative ones. Jahan lines pass hain, meaning they are densely packed, the field is strong. And remember these 3 golden rules for your board exam. Field lines literally never cross, they never close in on themselves to form loops, and they always enter good conductors at exactly 90 degrees.
Now what about continuous charge distributions? Take a look at a charged ring. The field at the exact center is 0, but as you move away along the axis, it peaks before fading out. एक बहुत ही common PYQ है about this exact peak. The maximum electric field occurs exactly at the distance x equals plus or minus a divided by the square root of 2. Seriously, इस value को बिल्कुल रट लो. It comes up all the time.
Next up is electric flux, denoted by phi. Simply put, it's just the number of field lines passing through a given area. Mathematically, it's the dot product of the electric field vector and the area vector, giving us Newton meter squared per coulomb. Because it's a dot product, it hits its maximum tub-jub field surface के बिल्कुल perpendicular ho. Grasping this is absolutely essential for understanding Gauss's law.
Okay, part 3, the electric dipole. Moving right along, we are now entering the territory of one of the absolute highest frequency previous year question topics.
Let's look at the specific definition of the electric dipole moment, or P. It is a system of 2 equal and opposite charges separated by a very small distance denoted as 2a. The magnitude is simply the charge q times that distance 2a. But pay super close attention here. It is a vector and it strictly points from the negative charge to the positive charge. Also, its SI unit is coulomb meters. Exam में जल्दी में please इसको centimeters मत समझ लेना. Big mistake.
Usually we calculate the dipole's electric field at 2 main locations, the axial line and the equatorial line. When your distance r is much greater than a really beautiful shortcut emerges. The electric field on the axial line is exactly twice the magnitude of the equatorial field at the same exact distance. Axial equals 2 times equatorial. Direct formula-based questions aate hain is par, so keep it in mind.
And you know, this isn't just abstract math. Take a real-world water molecule. Oxygen is highly electronegative, meaning it pulls electrons away from the hydrogen. Because the molecule has a specific 105-degree bend, those dipole moments don't just cancel out. Instead, they add up to give water a permanent net dipole moment. Yahi main reason had that water is such a fantastic solvent for life.
So, what actually happens when we drop one of these dipoles into a uniform external electric field?
Well, the net linear force is 0. However, because the forces act at two completely different points, they create a couple, which results in a torque. The formula is a cross product, tau equals P cross E. This torque essentially acts to rotate and align the dipole's axis perfectly with the external field.
All right, Section 4, Important Formula Recap. We've covered a massive amount of theory, and now it's time to distill it all down into a high-value cheat sheet.
I highly recommend taking a screenshot right now. ये सारे formulas literally tips पे होने चाहिए. First, Coulomb force is F equals Q times E. For an infinite charged plane sheet, which is a classic Gauss's law application, E equals sigma divided by 2 epsilon naught. Notice how it doesn't even depend on distance. And finally, the dipole torque magnitude is P(E) sine theta. Lock these in your memory.
And finally, Section 5, Exam Tips and PYQs. Let's move to our actionable strategy section, focusing strictly on how you can score those top marks.
Okay, here are your absolute must-know PYQ alerts. Bo kaman galtiya jo har halme avoid karniya. Number 1, remember, the unit of dipole moment is coulomb meter, not centimeter. Number 2, electric field lines literally never intersect. You mathematically can't have two different directions of force at a single point. 3, always use the superposition principle for multiple charges. Calculate the vectors individually, then add them up. And 4, keep your sign conventions super strict when plugging values into Coulomb's law.
And we did it! That was a complete, high-speed run-through of electric charges and fields. Are your concepts fully charged up? I'll leave you with a final thought to ponder before your exam. We know exactly how fields behave in a vacuum, right? But what exactly happens to all those electric field lines when we place a solid metal conductor right in the middle of them? Think about that. If this quick recap helped you out, be sure to share it with your friends preparing for Class 12 Physics, and follow BioCore Notes for more quick revision videos, notes, PYQs, and exam preparation content. Good luck studying!